In this video, we are continuing section 2.2 on equations of lines, and we're going to talk about how we can find the intersection points of curves. So I want to do this with an example. So I want to find the point of intersection of L1, which is this line, and L2, which is this other line, and then sketch the graphs. Okay, so how can we do that? So I want to begin by giving you an opportunity to try this. So pause the video for about 3 minutes and try this question. See if you can remember how we can figure out what to do to get an intersection point of two graphs. 4, 3, 2, 1. Pause the video, pause it, and try this for about 3 minutes. All right, so hopefully you did that. Hopefully you paused the video and tried it for about 3 minutes. So here's what I'm going to do. You might remember that when you find a point of intersection, you sort of set the equations equal. To be able to do that, I need to isolate the same variable in the two equations. So maybe I'll try to isolate y. So in the first equation, I'll get 2y by itself, and I'll move over that 3x, so I'll get negative 3x plus 7. And then if I divide 2, I'll get y equals, each of these terms will get divided by 2. I'll get negative 3 over 2 times x, and then plus 7 halves. All right, now let's isolate y in the other equation. So in line number 2, I'll get negative 5y equals negative 2x minus 8. And then I divide the negative 5. So dividing a negative number will change those signs. I'll get positive 2 over 5 times x, and then plus 8 over 5. Okay, so now that I have the same variable isolated in both of the equations, this is what y equals in the first line. This is what y equals in the second line. Well, at the intersection point, those y values got to be the same. That means we should be able to set these equal. Set these equal. Okay, so doing that, we get the first equation, negative 3 halves x plus 7 over 2 equals the second equation, 2 over 5 x plus 8 over 5. Okay, so now let's bring all of the x terms to one side, everything that doesn't have an x to the other. So I'll keep 2 over 5x where it is, because I like that it's positive. And then I'll move over the negative 3 halves x. So it gets added, so plus 3 halves x. And then I'll keep 7 over 2 on the left, and I'm going to subtract the 8 over 5. Okay, so I am either subtracting or adding fractions on both sides. So we will have to get some common denominators. Okay, so this first fraction, I got to multiply it by the other denominator, top and bottom, so 5 over 5. The second fraction, I got to multiply by the first denominator on top and bottom, so 2 over 2. All right, so similarly on the other side. So on the other side as well, first fraction, multiply it top and bottom by 2 over 2, the other denominator. And second fraction, I multiply top and bottom by 5 over 5, the first denominator. Okay, so doing this, this first fraction, well, on the bottom, I'll get 5 times 2, which is 10. And then 5 times 7 was 35, minus 8 times 2 is 16. Okay, so that's what I get on the left-hand side, equals, on the right, equals, my denominator is 2 times 5, which is 10. And in the first fraction, if I multiply the numerators, 2 times 2x, well, that's 4x. And then plus, multiplying these other numerators in the second fraction, I get 3x times 5, which is 15x. Okay, all right, so I got a fraction equals a fraction. And I can get rid of those denominators if I multiply both sides by 10. Okay, so that'll be nice because it'll cancel those denominators. 35 minus 16, that's 19. And then 4x plus 15x, that's 19x. And I just divide that 19 and I got x equals 1. Okay, awesome, I got x. But I want the point of intersection, so there's also going to be a y coordinate. to get the y-coordinate, well, I should be able to plug into either equation because both equations should be at the same spot at this intersection point. Okay, doesn't really matter. Maybe I'll plug it into the second one. If I do that, I'll get y equals 2 over 5 times x. X is 1 plus 8 over 5. All right, so this is 2 over 5 plus 8 over 5, which is 10 over 5. Oh, and that's nice because that's a whole number. That's 2. Okay, so my intersection point. The x-coordinate is 1, and the y-coordinate is 2. That is my intersection point. So the final part of this says, sketch the graphs. Let's just verify that this seems like a reasonable thing, that this is the intersection point. So I'll draw some axes, and then I'll draw some axes here for x-axis. Okay, and I'll draw these two lines. So L1, its y-intercept is at 7 over 2. 7 over 2, that's something positive. And then it's got a negative slope. Negative slope, so it'd be going downwards like this. It'd be going downwards like this. All right, so that is, I'm going to label that line L1. And then L2, my other line, well, it's got a positive y-intercept as well, 8 over 5. But 8 over 5 is a smaller number than 7 halves. So 8 over 5 is lower on the y-axis. And the slope of this line is positive. 2 over 5 is positive. So that is a positive sloping thing. Positive sloping thing. All right, so my line, that would be my second line, L2. So where they intersect, I think it seems reasonable that that might be a point like 1, 2. That is my intersection point. All right, and that is our answer.